Hey everybody, welcome back. This is College Algebra at College of the Sequoias. It's Math 35 here. If you're at a different campus or a different school, it might be a different number. Probably is a different number. We all have different numbers for some reason. And in this section, last section we looked at functions. In this section, 2.4 in our book, we're looking at linear functions. Linear functions make a straight line. Lines are normally written as y equals mx plus b. In function form, we say f of x equals mx plus b. And we don't want m to equal 0. I mean, it can. It's just a horizontal function. If m equals 0, it's a horizontal function. That's boring. And so if m is not 0, not equal to 0, then our domain and range are infinite. Negative infinity to positive infinity. And what can we do with them? Well, when you see functions, I want you to think like this. Let's say we have f of x equals 3/2 x plus 6. This is comparable to y equals 3/2 x plus 6. Same thing. So some things we could do with it. We could find the intercepts. Remember, the x-intercept is when y equals 0, which means f of x equals 0. So I set f of x equal to 0. I have 0 equals 3/2 x plus 6. Negative 6 equals 3/2 x. And I multiply both sides by 2/3 to get rid of the 3/2. And I get negative 12/4 is negative 4. X equals negative 4. So the x-intercept is negative 4, 0. The y-intercept I could do fairly easy here. This is when x equals 0. So I'm going to have f of 0 equals 3/2 0 plus 6 is just 6. So the y-intercept, when x equals 0, y equals 6. Those are our intercepts. And let's take a look at this line when we graph it. We'll do more on graphing in 2.5, but this really helps discuss what m is and b is. So let's put that y equals 3/2 x plus 6 up, or f of x equals 3/2 x plus 6. This is in the shape mx plus b. M equals 3/2, b equals 6. We said the y-intercept, we just looked at that on the last page, was 0, 6. That's my y-intercept. The 3/2, m says how far up on top over how far right on bottom. Which means if it's positive, it's going up. If it's negative, we're going to go down on top. Or if the negative's on bottom, negative on bottom means go left, positive means go right. So I'll illustrate both really right here. M equals 3/2. I could write as that, or it's the same thing as -3 over -2. This says go up 3 and right 2. That said, change colors for this one, down 3, left 2. So I go up 3 and I go right 2, puts me right there. If I go down 3 and left 2, it puts me right there. And you notice those points lie on a straight line. Okay? We'll talk about M more in a little bit. The domain here is infinite, negative infinity to infinity, as is the range. If an arrow keeps going, when you see something like this, what's the range? Well, does it keep going downward if I extend the line? If it keeps going downward like that, it means it goes all the way down to negative infinity. And if I look at it as it goes to the right, if it keeps going upwards, if I extend the line, it's going to positive infinity. Same thing happens when you look at the x values. As I go to the left along this line, I can keep going. It's further left and left and left as I go down to the ruler. And as I go up the ruler, the line keeps going further and further right. So that's one way of seeing that, how that works. Okay. We did mention increasing. This is an increasing function. Downwards would be decreasing. If m is negative or less than 0, it would be a decreasing function. And if it's neither increasing or decreasing, which means it does a little bit of both. Well, if it's neither increasing or decreasing, if it stays flat, this is a linear function. If it's neither increasing or decreasing, it means the up and down equals 0. M equals 0, which means f of x just equals b. We call those constant functions because the value stays constant no matter what value x is. All right? All right, let's look at some more ideas. The standard form of a line we use ax plus by equals c, where a, b, and c are real numbers. For example, 3x plus 4y equals 12. This, we can graph this fairly easy. Graphing is easy with intercepts. For the x-intercept, y equals 0. I replace y with 0, the 4y goes away, I just have 3x equals 12. We solve for x, we get 4. The x-intercept is 4, 0. The y-intercept, x equals 0, plug that in, 3 times 0 goes away. We just have 4y equals 12. So y equals 3, and we got 0, 3. And we could graph this. If we want to write this as a linear function, we need to solve for y. So 3x plus 4y equals 12. I can subtract 3x from both sides, and I get 4y equals negative 3x plus 12. I can divide both sides by 4, and I get y equals negative 3/4 x plus 12 over 4 is 3. And then I can replace the y with f of x. F of x equals negative 3/4 x plus 3. This form of the equation, when we have f of x equals mx plus b, is called the slope-intercept form. So we'll look at that more in a second. Let's take a look at this. Let's graph this. Remember, we're looking at f of x equals mx plus b. And we found the intercepts earlier, didn't we? The x-intercept was 4, 0. The y-intercept is 0, 3. We put a point at 4, 0. We point a point at 0, 3. And we connect the dots. Put a little arrowhead on each line to show that it keeps going. And that's our graph. If we take a look at compare these, b equals 3. They call this slope-intercept because that's the intercept of y right there. B equals 3 is the y value for the y-intercept. Or for for y-intercept. I got distracted myself for a second. That's why they call it that part slope-intercept. M equals negative 3 over 4, or I could write it as 3 over negative 4. This one says go down 3, right 4. And that says go up 3, left 4. So if I added more dots in, up 3, left 4, notice it appears on the line still. So the 3, up 3, left negative 4 leads me to that point. The negative 3 over 4 is that point. And what it does, M is called the slope. And it's what changes as we move along the line? So the top part of the fraction is a change in the y value. They often use this symbol, delta. This says delta y. And the bottom part is the change in the x value. It's the left-right, delta x. You will see these again when you get later on, delta y and delta x. And what this is really giving you is how much do you rise in the graph over the run in the graph. Rise over run. We are assuming we don't want the denominator equal 0, so the change in x, the delta x, can't equal 0. Otherwise, we have something breaks the fraction. If we don't have a change in x, it's a vertical line. I'll talk about that more in a second. So I said m is slope, rise over run. If you have 2 points x1, y1 and x2, y2, we can say the rise is the difference between the 2 points, y2 minus y1, over the difference in the x points, x2 minus x1. This is equivalent. We could subtract them in the opposite order, y minus y2 over x1 minus x2. We normally, you will see it frequently as y2 minus y1 over x2 minus x1. That's golden stuff right there. This is the slope. Or how much does the line go up and down increase or decrease if it's negative when we move right 1. This stuff comes up a lot. I can give you an example that you'll see in physics and stuff like that. Let's say I start here and let's say I can drive in a straight line to school. Straight line to school is 2 miles away. And let's say it takes me 10 minutes to drive. So my position changes by 2 miles as my time changes by 10 minutes. This, in physics, we would see delta x over delta t. Change in distance over a change in time, 2 miles over 10 minutes. We don't really talk about things in miles per minute though, do we? I could multiply this bottom by 60 minutes, or 1 hour equals 60 minutes. So I'll multiply the bottom by that. I get 2 miles and 10 over, the minutes cancel out. I've got 10 over 60 is 1/6 of an hour. We do a little bit of math. This is 2 times, we multiply by the reciprocal on top and bottom. 2 times 6 is 12, and I've got miles over 1 hour. 12 miles over 1 hour, that's 12 miles per hour. So that's something that we do in physics. And this is a change in position over time. This is something you'll look at in calculus. So this stuff pops up a lot as we're going on through things. If we've got f of x equals mx plus b, this is x, this is y, or f of x is the vertical axis. For increasing functions, as we go from left to right, it goes up. It's a positive vertical increase over a positive increase in the right. Increasing functions have a slope greater than 0. Decreasing functions, and it doesn't matter how slowly it decreases, it could be really slowly like that. Decreasing functions have a negative slope. And finally, we have our constant functions. Constant functions. What's going on with the slope here? We have 0 rise over a change in x. 0 divided by any value is 0. Constant functions have a slope of 0. F of x just equals the y-intercept. What about a vertical line? Red for the vertical line. If I have a vertical line right here, vertical lines, we have a change in y over a change in x, but x is not changing. We're not going left or right. We've got delta y over 0. This doesn't work. No. Vertical lines don't have a slope. They're called, the slope is undefined. It doesn't have a value because we can't divide by 0. Okay. If we're given 2 points, we can find the slope. Using m equals y2 minus y1 over x2 minus x1. Let's look at an example. Let's call point P -2, 4, and Q is 2, -6. So I'm going to treat this as point 2 and point 1. So here I've got m equals y2 minus y1 over x2 minus x1. I like putting in the fraction line and the minus signs and then replacing the values one at a time. If the p is 0.2, then x2 is -2 and y2 is 4. And the y2 goes in the upper left, the x2 goes in the lower left. And if q is 0.1, then x1 is +2 and y1 is -6. -6 and the function goes in the upper right, or in the slope goes in the upper right, and x1 goes in the lower right. I've got 4 minus -6 is 4 plus 6 is 10 over -2 minus 2 is -4. If I simplify that, I've got 5 over -2, and I could write that as -5 over 2 if I wanted to graph it that way, or we can put the negative out in front. Why don't you try changing the order? And what I mean by that is make p -2,4 equal 0.1, and q is 2 -6, make that equal 0.2. Go through and work that out real quick. I'll assume you paused it and did. I've got m equals y2 minus y1 over x2 minus x1. You can flashcard that to memorize it easier. My y2 is, let's see, let me put in my fraction bar and my negative signs. y2 is the y value on q is -6. y1 is the y value on p is 4. x2 is the x value on q is 2. And x1 is the y value, or x value on p is -2. -6 minus 4 is -10. 2 minus -2 is +4. And this simplifies to -5 over 2. Same slope. It doesn't matter which one you label x1 or 0.1 and 0.2. But don't mix it up. If you put the 4 on the bottom here and the -2 on the top, the things aren't matching up correctly. It's going to be wrong. Let me give you guys another one to try. So find the slope. From -3,8 to 5,8. I'll assume you paused it. y2 minus y1 over x2 minus x1. Since it doesn't matter which one I'm doing, I'll make the 0.2 that set and 0.1 that set. That way I've got positive numbers in front. I got a minus sign on top and bottom like that. My y2 is 8 and my x2 is 5. My y1 is 8. My x1 is -3. I get 0 over 5. If you leave it like that, MATLAB is going to mark you as wrong, and I'm going to mark you as wrong if you do in reality. 0 divided by 5 is 0. And recall, we have no change in y. No change in y means a horizontal line. let's say you have an equation you want to find the slope. So finding the slope from an equation. All you gotta do is isolate y or solve for y. And then you're in the form y equals mx plus b, and your slope is n. So let's say we have 2x minus 5y equals 10. I can subtract 2x from both sides. And I can divide everything by -5. And I get y equals -2 over -5. The negatives cancel out. I've got 2/5 x plus 10 divided by -5 is -2. And to answer the question, to find the slope, m equals 2/5. Take a drink of coffee real quick. This is the 4th video I've made today. Up at 6 a.m. bright and early making videos for you guys. So what are some examples of these in real life? So we could look at economics and business. That's a common one that people see. We have things like the linear cost function. And they'll say C of x equals mx plus b. So C of x says cost function. The mx plus b makes it linear. M, the slope, is the cost to produce one item. This might include materials, labor, etc. B are fixed costs. Things you pay even if you don't produce anything. Nothing. This includes things like rent for your office space or factory space, utilities, you got to pay for electricity, water, stuff like that. Another name for these things, they're also called overhead costs. They also have another function called the revenue function. Revenue is money coming in. So if you're selling something, every item you sell gets you a specific value, it gets you more money. So if you sell one item, so let's say it costs $2. You sell one item, you get $2. You sell two items, you get $4. You sell three items, you get $6. They tend to write this as P times X, where X is the number of units sold. And P is the sales price. And so we've got the cost function and the revenue function. What businesses care the most about, though, is the profit function. P of X is R of X minus C of X. Profit equals revenue minus cost. All right, let's look at an example. And not all business models have a linear cost, so we're going to assume a linear cost model. Assume linear models. And we also want to assume that all the products are sold. So let's look at an example of this. Let's say our fixed costs, rent and utilities, stuff like that, is $2,400, $2,400. And let's say we're producing toys. And the cost to produce the toy, it's an expensive toy, let's say it's $120. And the retail price for the toy is $150 per toy. How many toys must we sell? Must be produced and sold to break even. Before we break even. Any toys after that will lead to a profit. Any toys above this lead to a profit. So my cost function remember, C of X is MX plus B. We have our overhead. We have the cost it takes to produce one toy times the number of toys we make. Let's say we make X toys. And even if we produce no toys, we still have overhead costs, $2,400. Our revenue function is just the price times the number of toys. Retail price times the number of toys is 150 times X, because we sold everything we produced. So profit is P of X equals R of X minus C of X. The profit function is, I've got 150X minus 120X plus 2,400. And I stopped writing the dollar signs down, but it is in terms of dollars. We distribute the negative sign and gather like terms. I've got 30X minus 2,400. What this is really saying, if I produce 0 items, 30 times 0 is 0, I'm out $2,400. I had to pay my rent, I had to pay my utilities, I didn't produce and sell anything, so I have a loss. The break-even point would be when profit equals 0. So let's look at that on the next page. Pause that if you need it up a little bit longer. So I've got P of x equals 30x minus 2400, and the break-even point is at 0. So I solve for x. 30x equal, I add 2400 to both sides. 30x equals 2400. Divide by 30, and I get x equals, the zeros cancel, 240 divided by 3 is 80. X equals 80 toys. That's the break-even point. I told you anything a lot higher than that is when we make a profit. How could I show that? How can I show a profit is higher? Means more toys. A profit is got to be when your profit function is greater than 0. P of x has to be greater than 0, which means 30x minus 2400 has to be greater than 0. Add 2400 to both sides, we get 30x is greater than 2400. Divide by 30, and I show x is greater than 80. That's why I said higher than 80 toys. Okay? And so profit begins at 81 toys. That's what you can expect in this type of section. It's just graphing or looking at how the linear functions work. Looks at a couple models and examples. They'll give you different types of scenarios, but this was an economics one. We will finish chapter 2 next week. Peace. Have a good day, everyone.